So in this one, we're going to go up a hill instead because on the last one we worked on going down a hill. Okay, so in this one, imagine you're on a cat skateboard. There's a cat on a skateboard and he's going to travel up the hill instead of down it, okay? So what we do is we look at the exact same thing we did last time. We have 4 pieces that matter: V initial, height initial, V final, height final. Okay, we need these pieces. So what are these pieces for this scenario? Okay, so let's go ahead and write them. V initial is equal to what over here? If you take a look at what we have, V initial, I've written down, it's 20 meters per second, so V initial is 20 meters per second. Snazzy. Now, height initial. What is the height right here at the bottom of a hill? Well, hopefully the bottom of a hill is as far as it goes down. So that means that height initial should be 0. Okay, next on our conservation of energy, we have V final squared. What is the final speed at the top of the ramp? If you think about the cat coming up on its skateboard, eventually it'll roll up to its maximum height and it will stop. So VF, in this case, is equal to 0. Height final is equal to some number, and that's what we're looking for. So once again, just like last time, all you got to do is you have to place the numbers in the conservation of energy and then solve for what you're missing. Okay, so let's do that. First off, let's cancel the m's because they're in every single term. Nito burrito. 1/2 times our initial speed, which is 20 meters per second. We're going to square that. Plus G 9.81 times a height initial of 0 is 0. So G times 0, so that whole term goes away, equals 1/2 times 0 squared plus 9.81 G times meters per second squared, sorry, times height final, which is what we're looking for. So we cancel this term out. Let's go ahead and rewrite this so it's a little less hectic. Okay, so this is 1/2 times 20 squared equals 9.81 meters per second squared times height final. So now it's just a matter of multiplying stuff out, okay, and doing the mathematics portion of it. We've already done the physics. We've set up what is important. We've done the physics. Now it's the math part. So we take 20 squared, which I hope you know is 400. You take that and you multiply it by 0.5, which is 1/2, and that should give you 200, right? So this whole term on this side is going to be 200 meters squared per second squared equals 9.81 meters per second squared. To find the height final, we simply divide by 9.81 meters per second squared on both sides, getting the height final by itself, canceling a whole bunch of units and giving us 9.81. A height, that's kind of weird. Is that right? It seems kind of high. I'll double check this number. Height final of 20.39, if we round, meters. Cool. So once again, all we did was we started at the bottom of the ramp, going 20 meters per second. We slowed to a stop at a height of, based on our problem, 20.39 meters. It just seems very large. I'm going to double check that. 20 times 0.5 divided by 9.1. No, that's right. That's weird. I don't know, just a lot smaller than I expected. I would have expected a much larger number. Anyway, so yeah, there you have it. There it is, guys. Now it's just a matter of remembering this process, okay? Remembering who's who. What is your initial speed at the bottom? What's your your final speed at the top? What's your initial height at the bottom? What's your final height at the top? Knowing what those 4 terms are will tell you how to solve your problem.